Hey guys, today I'm going to be going over some notes I took on kinetics. Okay, so this is about reaction mechanisms, and I really want to talk about the elementary steps. So, only for elementary steps can you determine your rate from an elementary step. What I mean by this, in a multi-step reaction, meaning two or more, the slowest elementary step will determine the rate of the whole reaction. So, let's say you have these two reactions and they will explicitly tell you this one is slow, this one is fast. You look and you take the slowest one. This is going to determine your rate. And now, how do you determine the rate? This is a method only for elementary steps. You look and you notice that this is an A plus B yields to C format, right? So if you know it off the top of your head, which you eventually will, you will know that an A plus B format is bimolecular and your rate is going to be in this format. If you don't, probably learn it, but A plus B, which means that my rate is going to be K of NO2 times the rate of F2. That's your rate. But let's say it was 2 NOF2. It would be NO to the 2. And this is something you can only do in elementary steps. Only in elementary steps, okay? The key ideas here are basically just how the reaction mechanisms are set up and what, like an intermediate. So basically, an intermediate is it's always canceled out, but it's a product of one step and then a reagent of another, meaning that it's created in a step, and like right here, fluorine is created, fluorine gas, and then it is a reagent here, but then it disappears, which means it'll always be canceled out. That is what an intermediate is. Then we have a catalyst. A catalyst speeds up a reaction, but it's not part of the overall reaction, meaning that so right here, we see NO2. We see that NO2 is not part of this reaction, but it is used, right? It's not in the overall, but it's used. As we observe this step right here, there's no NO2 here. So I thought that was, one of these is supposed to be NO. Okay, so no, it's not. NO2, okay. So I thought that was interesting. Molecularity. The number of species that must collide to produce the reaction indicated by the step. That's pretty straightforward. Elementary step. These are elementary steps. This is the only method you can use to look at the coefficients. The only method. Only. Activation energy is the energy required to ignite the reaction. So basically, if you have this graph right here, your activation energy is right here, your transition state or your activated complex, whatever. You must have, in order for a reaction to occur, so kind of like off this, the collision model, in order for them to occur, your activation energy must exceed this energy here or it won't occur. It could be equal to, but it must exceed or be equal to. And that is it.